Welcome everyone to Pomodoro Joe for Sunday, January 8th, 2023. And today we are doing LeetCode problem 149, max points on a line. And this is a hard problem. Very simple problem statement though. Given an array of points where points at I is equal to some xy, represents a point on the xy plane. Return the maximum number of points that lie on the same straight line. And then they have some examples, giving some lines, and then they have some constraints. So there are fewer than, or they're between 1 to 300 points. Okay, and then the points can lie anywhere between negative 10 to the fourth to positive 10 to the fourth. And all points are unique. Okay, so a couple of those constraints are important. The fact that all the points are unique is important, so we don't have to worry about removing duplicates. The fact that we only have 300 points to go through means that we can probably brute force this, essentially. We will go through every single combination of points. Okay, so here's the plan. 2 points define a line. So for every pair of points in our input list, we will calculate the line equation. Then for every point that lies along the same line equation, that gives us a set of points. And that's how we're just going to handle this problem. Okay, so unfortunately, this one is going to require us to either remember or derive some geometry equations having to do with points defining a line. So let's get started. 25 minutes on the Pomodoro timer, and here we go. So the first thing that we need to remember or derive is an equation for a line given 2 points. So the basic equation for a line given 2 points is you have a y1 minus y2 divided by x1 minus x2. So given points 1 and point 2, this is going to define our slope essentially. And that is going to equal some y1 or some y minus y1 divided by some x, some new x minus x1. So this is basically how we're going to calculate our line equation. So we're going to move some of these over. We're going to move this side over to this side or vice versa. It doesn't really matter, but we'll essentially transform this equation into something a little bit easier to understand, or easier to work with at least. So that's going to be, we'll have some y minus y1. And that's going to equal our slope here. So that's y1 minus y2 divided by x1 minus x2. And that whole thing is going to be multiplying our denominator from the other side, which is this guy here. So that's x1, or x minus x1. And then we can add y1 to both sides to just get y is equal to this whole thing plus y1. All right. Okay, so now that we can figure out an equation for a line, how do we use this to our advantage in figuring out this max points? Well, here's the solution, or here's the plan at least. We will go through every pair of points in our set of points, or in our list of points here. And for every pair of points, we can calculate some line equation that's essentially a slope and an intercept. Using those two pieces, that'll be our key. That's our line equation. And any point that matches that line equation will fall along the same line. So we'll keep a dictionary of all of our line equations, and then we'll keep a set as the value for all the points that fall along that same line, that have that same shared line equation. Now there are a couple of gotchas in here, and I'll point those out as we go. And those gotchas are these edge cases, like if you have a vertical line or a horizontal line. Those things are going to cause some problems. And one other gotcha, this one I will just point out now. They don't say this here, but I happen to know from previous experience that if you have a solitary point, then that one can constitute a point on a line. So the minimum answer here, given at least 1 point, is 1. Let's get down to some coding here. So we're going to need some dictionary to start with. So we're going to call this like lines. And this is going to be a mapping of our equation to our set of points. So that's one thing we need. So the other thing we're going to need is a result. And we're going to start our result, I'll put it above here. We're going to set it equal to 1, because if we only get 1 point, we can still have a line that passes through that point. So we'll return 1. And then we will return our result once we've finished. Okay, now we get down to business. For, and we're just going to say I in range points. Oh, I should do length dot points. So we're going to go through every single point, and then for j in range, and we'll go from I plus 1, because we don't need to start at, we don't want to map a point to it, or we don't have a line between the same point, like 1 point. So I plus 1 gives us another point, and we'll still go through the length of points. Okay, so now we can have point 1 is equal to points at I, and oops, points at I, and point 2 is equal to points at j. Now given our 2 points, we're going to calculate the slope, and we're going to calculate our intersect. So the slope is going to be 0.1 y, whoops, 0.1 y's minus 0.2 y. And that whole thing is going to be divided by 0.1 x minus 0.2 x. And so that's going to give us our slope, but we still don't have our full equation. That gives us this first part here. So our constant is our slope times our negative x1, and then we need to add in our y. So plus we need y1, so that's p1 at 1. Okay, I think we got this right. I hope we got this right. Now we have to deal with a couple of these edge cases that I wasn't covering before. So it could be that if these are both, so this is our x coordinate, so if these are both on the same x coordinate, now we have a vertical line. This is a 0, and that would be a divide by 0, which we want to avoid. So first thing we'll do is say, if our x's are the same, so if our p1 0 is equal to our p2 0, so we're on the same x coordinate, which means that this is going to be a vertical line. We're just going to set a slope equal to, let's just say it's infinite. We just want some number that we can represent our slope. So we're going to say our slope is infinite. And then if our P1, so similar to a horizontal line, here I'll mark this. This is a vertical line. Now this one's going to be horizontal. So if our P1 at y is equal to P2y. Now again, we're just going to set slope equal to 0. It's not, these are not technically, I think, the right numbers for these, but we need something to represent a slope. And then the very top here though, I want to make sure I haven't already set my slope. So I'm going to say we'll have some slope and we're going to set it equal to none to begin with. Slope is equal to none. Then we'll set our slope. All right, and I think we want to do the same with our c. So if slope is none, then we'll set our slope and we'll set our c. If our slope is infinite here, then we're going to set some c value and we'll just set it equal to our x, because that's where it will cross the x-axis. So we'll set it to x, and then for this guy, we'll just set it to the y-axis, the y value, because that's where it's going to cross the y-axis. So now that we've defined our slope and our intercept, we can have some key, and our key here is going to be that slope and our c. And our value, well, our value is going to be a set. So first we'll just do, if this key is in our mapping, what did I call this? I call it lines. I'm running out of time here. All right, if key is in lines, then we'll just say lines at key. We're going to add our 2 points. So we'll add P1 and we'll add P2. Otherwise, if we don't actually have anything yet, we're going to say lines at key is going to equal a new set, and then we'll add P1 and P2. Okay, now that we've gone through and calculated all of the different possible lines, now we need to go find the one that has the most points on it. So for line in lines, if line.count, sorry, that's the key actually. So this is for the key in lines. If lines at that key, which gives us a set, if the length of that set is greater than our result, then our result becomes the length of that set. So basically we just want to say the result is equal to the max, I'm running so short on time here, of our result, and that set. If there are more points in that set, then our result gets updated to a bigger result. So P1 and P2 unfortunately are lists, which means that we can't add them like this. So these have to be tuples. So I will convert the list to a tuple. Same thing here. All right, and then I'm just, because I don't have a lot of time and I don't want to type it all out, I'm just going to do this. And that works. Let's see if we pass all the other tests. I'd be surprised if we do. Hey, and we pass. All right. As you can see, it's not the best solution. It only beats 10% of the other submissions in terms of memory, which is not good at all, but it beats 60% in terms of runtime, which is actually not too bad. All right, there are some things we can do to make this better. There's some things we can do to improve our runtime and our memory, but I'll leave those as an exercise to you because I am out of time. So I hope you enjoyed this, hope you learned something. Give this one a shot. It's actually not as bad as it seems. I'll leave some links in the description for some helper websites you can check out, and go out and write some better code.